Let us look at the EI instruction and the DI instruction. Both these instructions only occupy 1 byte. The EI stands for enable interrupts. So if this instruction you have written and this gets executed, then it is going to turn on all the interrupts that can be enabled by the software, that can be enabled by your program. Similarly, if you execute the DI instructions, it is going to disable all the interrupts which can be disabled through your program or through your software. Now here in this slide, what we are looking at is the SIM instruction, meaning set interrupt mask kind of an instruction. In this instruction, what you have to first do is you have to load the contents of your accumulator with a particular set of zeros and ones. Now what will you load as the content of the accumulator? So let's look at it from this diagram. So for example, if you want to mask either the interrupt RST 7.5 or 6.5 or 5.5, then what you have to do is first you have to put a 1 at location bit number 3 of your accumulator. This has to be made to a 1. Why? Because this is saying it is the mask set enable. So first you have to enable your masking process, which means this has to be a 1. Then if I write a 1 at this place, which means that I am masking my RST 6.5. So which means if I load a particular word in my accumulator, which is basically 0, 0, 0, 0, 1, 0, 1, 0, if that is the content of my accumulator, and after that if I execute the SIM instruction, then it means that I have masked which particular interrupt. I have masked 6.5 because here I wrote a 1 and I also had enabled my masking process. So here also I had written a 1. So in that case it is going to mask RST 6.5. Similarly, if you want to mask RST 5.5, then obviously here also you will have to write a 1. Please make sure that whenever you are using this particular binary notation, you have to make sure that to mask any of these three interrupts, you have to make sure that the mask set enable is also made to be a 1.